Hi, everybody. My name is Deven Patel. I'm the president, CEO, and a co-founder of Global Institute of Stem Cell Therapy and Research based in San Diego, California. It's founded by two co-founders, myself and my partner, Dr. Anand Srivastava. We're the two co-founders who started this journey 24 years ago, around year 2000, 2001. And GeoStar was established, short form of Global Institute of Stem Cell Therapy and Research is GeoStar, based again, San Diego, California. And we established that in 2008. And I wanted to share a few findings of our team and our scientists who are working in the field of stem cell research and gene therapy and cancer research for over 3 decades. Thank you very much. And my topic is human longevity and how these new technologies and our understanding of this new science is helping us to building a new technologies and a science where we can live much better, healthier life in terms of our mental conditions, our physical conditions, and wanted to share with you how we're extending the even lifespan for many people. And life expectancy has increased across the world in the last 200 years. It has doubled from 35 years to 70 years. So there are so much possibilities of living much better, healthier, and longer life due to new, better nutrition, clean water, clean sanitation, better healthcare, better antibiotics, vaccines. All this technology combined in the last 100, 200 years has increased or doubled our lifespan, and that requires further improvement for things around our lives. And to understanding the aging process and its impact on our human body, there are 3 main characters on the gene level, where the DNA damage, telomere shortening, and a decrease in the mitochondrial efficiency. And that leads to cellular level of changes, where that in turn leads to metabolic diseases, cardiovascular disease, neurodegenerations, and chronic inflammation, and many more things. And how the role of genetics plays in this aging. So there are 3 areas I wanted to quickly talk. One is the longevity genes, epigenetic factors, and personalized approach. Longevity genes are the people who have a certain genetic variant that they're staying in certain areas, like, for example, in Japan, at certain areas where people live easily over 100 years because of their certain genetic variant. The epigenetic factors, which is the lifestyle and environmental factors that influence the different gene expressions and how we age and the quality of life. And the personalized approach, where we are further understanding much better at the genetic level, where we can do the genetic profile, which in turn help us do the preventive treatments for the further better longevity. And there are 3 areas I'm going to talk in these emerging therapies and treatments in longevity. One is a cellular therapy, second is a tissue engineering, third is a gene therapy. So cellular therapy is basically stem cell research and regenerative medicine, where we basically use the power of stem cell to repair and regenerate anything that is damaged and degenerate in your body. Tissue engineering is a new exciting field where we are talking about basically 3D printing the organs. And in the gene therapy is also a much exciting field now. 20 years ago it wasn't, but now in 2024 it's much exciting. Several gene therapies are being approved by US FDA, and that is where somewhere we are going to more. You will see that in the cancer space, more of a blood cancer space. You will see expansion of the gene therapies. So first, we're going to talk about the cellular therapy and how that can be used. For simple use of cellular therapies in a tropical approach, without injecting anything, is creating skincare type of products where you put stem cell derived molecules, growth factors for cellular renewal, collagen boost, and some certain targeted repairs, sometimes alopecia, hair growth, certain skin conditions, old scar, wrinkles. Those are peripheral surface. This is not a deep science, but people are using and people are liking it. And then there's much better outcome than a regular skincare products. On a cellular level, when we're talking about, I'm just going to talk about the hair growth, where we go and inject stem cell at the upper skin layer in your for your hair to stimulate the hair growth and for the basically hair fall, to help rejuvenate the hair follicles. And we have seen very good results of many patients where we have been able to regrow their whole hair, also helping in the gray hair to turn into the much lighter, darker hair. So this is one of the used case that we can share with you, as we have treated so many patients with this kind of condition. Another area I wanted to talk about is the liver regeneration in the cellular space, where you can get the bone marrow aspiration or cord blood, which consists of many different, several cells and MSCs and HSC and EPCs. And this is an in vitro talk we are talking about, and that can be injected directly to the organ. This other option is umbilical cord divide MSCs, mesenchymal stem cell, that will, again, injecting directly to the organ, will help with the anti-inflammation, immune modulation, angiogenesis, and anti-fibrosis. And other method is a healthy donor, that you get the hepatocytes from that particular donor, and then you inject directly back to the liver. This is just one of the organ we have picked, and we have a publication that you can see at the bottom that we have published in 2019 for our study in this area. Second exciting field is a tissue engineering. That's an emerging field where we are talking about basically 3D printing the organ. There are two ways to do it. One, you do the cell culture, put those culture cell on the scaffold and put it into the 3D bioreactor and try to grow the tissue around that scaffold. The other option is to basically taking the 3D model, computer model, and then you 3D print with the bio ink. And then that you basically printing the one unit of that whole organ, and then taking that into the 3D culture bioreactor to actually growing the whole organ. So we're working in this space in a very primitive level. Even the industry is at a very primitive stage right now. But this is a very exciting field, actually, where we are working on the couple of things that I'll share further. And the importance of 3D tissue engineering in the three areas. In regenerative medicine, we are talking about basically printing the organs and replacing the organ. And drug testing, the 3D tissue model will allow you to eliminate the use of an animal model, reduce the cost and the time to test any drug. And organ shortage, we all know there's a tremendous organ shortage for the liver transplant, kidney transplant, heart transplant. So this technology can play a humongous role in addressing that issue. But this is not coming just tomorrow. It's going to take another 5, 10 to 15 years to really perfect this technology. In our organization, we have embarked on the bioprinting of the skin. Here you can see in the this space where basically it is more of a cosmetic purpose, burn cases or the wound markers, to how we can help producing and printing the skin, and then use it that as a basically in a cosmetic processes. This is just the organ bioprinting sample, how it may look like in future. And the third area is the gene therapy, which is again very exciting. And gene therapy is a revolutionary approach in a medicine, a CAR T. You all have heard how that is changing the whole cancer space and longevity space. And again, the role of gene therapy in the regenerative medicine is tissue regeneration, where basically we're taking the gene and inserting that gene and replacing the damaged tissue and organ. Or in stem cell therapy, it is more of a IPS cells, induced pluripotent stem cell, where we take the adult cell and we do gene therapy on it to make it behave embryonic-like stem cell, and then give it a signal to differentiate into any cell or tissue type. And similar thing can be work in the wound healing, where we can basically speeding or expediting the wound healing process, where these certain gene insertion will help the growth factor, which is essential for the healing process of the wound. Potential application of gene therapy for longevity that we are working specifically, telomere maintenance, where we are working with the telomerase enzyme to help the telomere lengthen back to its original length, and then slow down the shortening of the telomere. And cellular senescence, we are working to help new cell to slow down the senescence process, so that we can help slowing down or maintaining the aging or longevity process in a much better way. And rejuvenation, again, same thing. It's a huge field, and in that process we can help epigenetic changes and mitochondrial dysfunction to promote the cellular rejuvenation. And this is CRISPR technology. I'm sure all of you are very much aware of it. It's cut and paste technology, where we are developing a process in the blood cancer space. And future direction is very exciting. This is a very exciting slide for me, because what's going to happen in the next 5 to 10 years is there's going to be a fundamental changes in a policy and a priority of a policy making of the nations. And that will, in longevity space, okay? And that will lead into transition to age-friendly cities, to more of a longevity valleys, and the rise of the first longevity state maybe. And that in turn will create the competition in a private and a public sector to create a much better, much optimized technology for healthy living, that in turn citizens will demand for their much better healthy living and quality of life from their governments. So it's all going to come to the point where the legislators and lawmakers are pushing these policies and the sciences. So we are going towards, instead of the sick model or the disease model, towards the preventive model in the first place. And that's the exciting part of this entire longevity field. And conclusion, as we continue to unravel complexities of human longevity, the future hold exciting possibilities for extending healthy lifespan by leveraging the advancement in science, technology, and personalized medicine. We can empower individuals to make informed choices and embrace more vibrant and fulfilling life for every individual on the earth. Thank you very much. Any questions?
Hi, Deven. To check with you, like how soon your product is gonna live in the market. Sorry, you are mute.
Yeah, John, which product are you talking about? Are you talking about a skin product, 3D printing of skin?
Yes, 3D printing of the skin.
I would say minimum 5 years, minimum,
Okay,
to perfect the technology.
great. And what are the potential applications that you see?
Everything from wound healing to plastic surgeries to you name it, skin diseases, scars, so many applications, and many possibilities.
Okay, so currently your product is specifically focusing on the US, or is it global?
We are based in the US, San Diego, California, but the product launch will be global anyways, because once you get US FDA approval, it's very easy to proliferate the product or services around the globe.
So in what stage the product is? Like it's in phase 3 of clinical trials or
No,
4?
no, 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 no. We're in an early stage of developing in our lab. We haven't even reached the stage 1 or phase 1. We are in phase 2 clinical trial for diabetes type 2 right now, with stem cell with US FDA. That is another product we have, which is basically creating blood, red blood cells from stem cell. That is almost FDA ready, clinical trial ready product. So those are ready products, but the skin will take at least 5 years.
Okay, how potential are the results you're seeing currently in your lab?
We're very excited about it, and we see a lot of progress every day, and we're excited, and that's where we are investing all our time, money, and energy to develop the skin, because it's much easier to develop that versus 3D print the heart. You understand the difference, the
Correct.
complexities. So
Yes.
that's what we are concentrating right now, to perfect something that is low-hanging fruit, make that possible. Then the next complicated organ, like a kidney or liver or heart, or would be much better progression.
Great. We see a great potential on your research, and we wish you all the best on your progress.
Thank you very much. Thank you, everybody,
That
and
was a
it
wonderful
was
presentation. Thank you so much for your time.
thank you.